Hi, everyone. My name is Einstein Millan. I'm a software and data architect at WhitePrompt. And today I'll be talking about agents and large language models. So go ahead and hit that subscribe button, give us a like, and follow us for further tech talks. So as always, I like to do a quick recap of large language models and things that require us to reiterate on. So my last three or four tech talks, I've been touching upon everything that takes place in order for us to get results such as ChatGPT or interesting results from large language models. So you can think of them as digital brains that understand and generate human language. And they're behind many of the technologies that we use today, such as voice assistants, chatbots, translators, Alexa, etc. And they pretty much bridge the gap between humans and computers. So we become better at talking with computers or at developing interfaces to speak with machines. In the beginning we had zeros and ones, then we started with low-level languages. Now we're using language models to basically talk to computers, such as the way kind of Iron Man does with Jarvis. So enter LangChain. As soon as the large language models and chat models hit the market, us geeks began to find ways to put this in frameworks and put this in ways that makes it easier for us to develop applications on top of these large language models and chat models. So LangChain is one of the first frameworks that has moved forward with this endeavor. And it's just a powerful framework designed to harness the capabilities of large language models. It's kind of like a toolkit. So some of the key features of LangChain is connectivity. So you can integrate it with various data sources, making access to the information easier. They have many connectors, so to speak. They can talk to many databases such as Postgres, OpenSearch, S3 buckets. I think they have a list of over 20 different connectors just for databases. They also have connectors for Wikipedia, Notion, and much more. Slack, I believe, they have many integrations. So it makes it easier to have the large language model or the chat model interfacing with all of these sources of information. And it's not just about understanding the language, but it allows it to pretty much interact with its surroundings. So I think the sky is the limit here. We have so many tools as Internet of Things that when we perfect the art of large language models and chat models, the capabilities could be endless. So imagine being able to tell your refrigerator that you need to replenish your supply of potatoes, or that with a bit more sophistication in place, we could have it see what's in your pantry or what's in your fridge cabinets and say, hey, you're short on potatoes. Would you like to order you some? You say, yeah, go ahead and order me a pound of potatoes. And then you have these advanced supermarket services that integrate with your large language models and your refrigerator, and you can order potatoes or whatever. So I think of the Jetsons or the old shows where this was beyond our imagination, and today it's a reality. Another of the key features of LangChain is that it offers modularity. So developers can pick and choose the tools that they need, or they can provide the large language models, and large language models can select the tools that they need for a given task. So they're beginning to become smart enough to do these things. And at the heart of LangChain are agents. And in LangChain, agents are like chefs in a kitchen. And instead of rigidly choosing a recipe, they taste, adjust, and decide what to cook next. They're dynamic components that use language models to determine the best sequence of actions. And what makes them special is that traditional fixed systems have fixed actions, like a preset recipe. But agents in LangChain can adapt and change their actions based on the situation. This means that applications can become more flexible, responsive, and tailored to specific needs. So we can think of a chatbot that takes orders for a restaurant. And suppose you ask the bot to give you the total of an order and add tax. And you give the agent a math tool. So large language models are specifically known for not being good at doing mathematics. But it would be smart enough to say, look, I'm not smart enough to know the math. I can give the math tool the parameters and it can decide and do the math for me. So we're giving the large language models or the chat models capabilities beyond the large language model training, such as mathematics or perhaps hitting an endpoint or organizing information as output for an endpoint, such as a JSON structure or anything that we like to have. It constructs for us. So the agent class is something that they developed specifically for Python, and it contains a set of tools and methods to help you make all these connections and integrate all of these chains. So the agent class is the decision-making center of our LangChain chef. And it's the part of the agent that uses language models to decide what action to take next. So the agent receives a prompt, which is like a question or situation it needs to address. And based on this prompt, using the power of large language models, it determines the best course of action. It's like our chef deciding whether to add salt, stir, or turn up the heat. And it can also have customization and personality. We can tailor the agent, meaning that we can tailor the class. It means that giving our digital chef a unique style or personality based on the task at hand. Whether it's a friendly chatbot or data analyzing expert, the agent class can be adjusted to fit the role. So it's not all perfect. It's bleeding edge technology, and there are kinks in the armor and things that need to be addressed before it's production ready. And a great deal of these abstractions and paradigms are not really production ready. Some of them are, and that's basically depending on your use case and depending on the complexity of your scenarios or use cases. So one of the challenges is tool use. So large language models and agents love to use tools, and they don't always need to use tools. So knowing when to use a tool is like a chef deciding which utensil is best for the task. So sometimes the agents struggle with these choices. Over-reliance, which is something I alluded to a few seconds ago. So the chef shouldn't overuse salt. Agents must avoid relying too much on certain tools or actions. And then for every tool, there's an output that's brought back to the agent as observations. And how that's brought back or sent back to the agent is what we call output parsing. So sometimes it comes in a structure that the agent will not understand. So the tool will not be able to talk properly to the agent, and we get errors, or we don't get it in the structure that we need, or we don't get exactly what we're looking for. Another thing we struggle with is memory. Oh, I have a typo there, but I can talk about that. The memory, sometimes the conversations get large, and right now the models have a limit, a token limit. Fortunately, for example, OpenAI is expanding and extending the amount of tokens that these large language models have control over. There are some mechanisms for which that they use to play around with it. So sometimes they add a chain that makes a summary of the conversation. So it condenses everything and it gives enough context to the agent, so you don't overuse tokens. So you may say, hey, but wouldn't I be losing conversation context this way? So my answer would be, so how good is your memory? Can you remember a whole conversation down to the dot, or do you usually remember a condensation of the conversation? That being said, the idea of these things is that they go beyond human capabilities, and I'm sure that's not going to be an issue in the future. Another thing that agents struggle with is focus. So yeah, as it says, the chef want to ensure they don't burn the dish. Or sometimes when you ask a model a question, even though they're hallucinating, the model's hallucinating or the model's not giving the correct response, it'll double down on its previous answers from what it sees in the history to try to justify the answer, even though it's wrong. And then we have another challenge that we have is evaluation. So how do we measure the agent's performance? So it's akin to testing a dish, taste testing a dish to ensure it's perfect. It's a bit subjective. So there's a few publications and papers and frameworks that have been released in the last few months as to how to tell an agent how to best make decisions based on information it's receiving. So the latest one is React. There's others such as, I think it's One of them is acting, and then the other one is reasoning. And this is kind of a combination of reasoning and acting. So that's why it's named React. But there's others such as chain of thought, and they all have their limitations. But React seems to be the best one as far as reasoning is concerned and knowing what tools to use. But by the same token, it's the one that consumes the highest amount of tokens. So it stands for reasoning and acting. The chef, it's like a chef who not only thinks about the dish, but also acts swiftly to bring it to life. This framework combines the power of thinking, reasoning, and the ability to take an action. Interleaved reasoning and acting, meaning that in React, thinking and acting aren't separate. It's a dynamic dance where one informs the other. So imagine a chef tasting a soup and then deciding whether it needs salt and then immediately adding it. That's pretty much the synergy React aims for. And this was published, by the way, I believe, by the University of Princeton. So there's tools and brilliant minds behind these publications and research. And the prompt acts in React, they're the cooking instructions. They guide the process, ensuring the desired outcome. The prompts are flexible, allowing for adjustments based on the situation, much like a chef tweaking a recipe. So real-world applications of React, we have the hot pot question and answering example. So in tasks like hot pot question and answering, React shines by providing clear reasoning. It's like a chef explaining each step in recipe, ensuring clarity and accuracy. And it also avoids pitfalls, ensuring answers are not just quick, but also correct. There's something called the AlphaWorld example, and it just goes through a bunch of research. So it pretty much looks from one source, and it says it knows that it can't find the real answer, and it looks through various sources until it reaches the real answer. And with human oversight, React can be guided and corrected. So that means you can fine-tune these models. And fine-tuning large language models is not akin to the past way that we had to re-educate these models. Right now, we just, by having about 200 examples of prompts, you can fine-tune and correct your models. So this way you can also not only enhance the way it responds to respond more accurately and more precisely, but also you consume less tokens because there's less reasoning to reach the same answer. There's a huge competitor to OpenAI. Right now, since it's the hot topic, we're only talking about OpenAI, but there's Hugging Face, which is the open source of AI and machine learning. And they have a ladder, I believe it's AI and machine learning model ladder where everyone's competing for the best accuracy and best metrics for large language models, for computer vision, for neural networks in general, for prompts, fine-tuning data sets, etc. There's a whole bunch of stuff in there. Super interesting, and I suggest that you take a look. And there's a huge community collaborating to make these models and data sets, etc., a whole lot better. I must mention that Hugging Face and AWS have an agreement to compete in the AI and machine learning ecosystem. And they want to rival pretty much OpenAI and Azure, which have their own partnership. So AI is ever evolving, tapping into Hugging Face's updates and tools. LangChain ensures it remains at the cutting edge. So LangChain can integrate not only with Hugging Face, but also with Hugging Face and OpenAI. They're super flexible. So that's another plus for LangChain. So conclusion and forward path. As I've mentioned, this is not a bulletproof technology. It's bleeding edge. So there's a lot of kinks to the armor. There's nuances that we're seeing as we test and take these technologies for a spin. For the intricacies of LineChain and its dynamic agents to its innovative React framework, that's something we looked and touched upon. With Hugging Face as a valuable ally, our toolkit is robust and ready for challenges. So our goal is clear: to leverage these advanced tools and frameworks to create responsive, adaptable, and innovative applications. I make, again, the analogy to the chef. So we must use the finest ingredients and techniques to craft a masterpiece. Next steps: to navigate our project successfully, we'll assess the offerings of Hugging Face, React, and LangChain. ensuring we utilize them to their full potential. Continuous evaluation and adaptation will be our mantra, ensuring our solutions remain state of the art. Thank you very much. Have a wonderful weekend.